Okay, so now we have covered how to create databases, tables, and views, which means indexes are the last creation that we need to worry about with our DDL. Okay, so what are indexes? Indexes are all about how you actually access the data. So think about it this way. So if you, when we look through the data, we basically make a query that can do something like, for example, filtering a list of classes to be just all the classes taught by a certain professor, right? So if you were wondering what other classes does Otter teach, you could look through all the classes, look through the instructors, see what classes that I teach. That's fine for something like SPU. It wouldn't take that long because there's not that many classes and I don't teach that many either. But what if you're looking through a very, very large data? So big data, so you're thinking like Amazon products or census information. If you wanted to know, like for example, I've tried to Google all the people in the world that have the last name Kinase, which was it's a Japanese part of my name, and it's a very, very rare name, which there's like 50 something people in the whole world that has the last name Kinase. For something like that, without any indexing, basically you'd be looking at the index of all the people in the US or in the world for my search, and looking through every single record for that last name. That can be very resource intensive for very, very large databases like that. So what an index does is it speeds it up by grouping the entries together. The way I think of it is if you have a very large Excel file and things are randomly ordered, because we know that record order doesn't actually matter. Or maybe it's ordered by their primary key, which is some number like a social security number or something, has nothing to do with the last name. It'd be like using the sort function to sort the names alphabetically and telling the computer, hey, start when you hit the first Kinase. When you hit the last Kinase, you don't have to look through the rest of the database because you found them all. They're all grouped together, nice and neat. This would speed up the search tremendously if you could do that sorting function. So that's basically what an index does, is it groups together all the entries, giving a boundary of start looking here and looking here, nothing else matters, just to speed it up. So this increases the efficiency of data retrieval by bounds, especially for very, very large databases. But because it is a physical structure on top of your database, it also occupies space and makes your database larger. So there's the trade-off. There's always a trade-off. Every time we get faster, we have to trade off something else, right? So would we want to put indexes on every field in the entire database? No, it will get so big. So it's strategic thinking, looking at what is likely to be accessed a lot, like thinking from a user perspective, like how would people be looking for data, and what is large enough that this would actually be required. Will you need this for your projects? I doubt anyone's going to use a data set large enough that indexing would be required. Could you put it on there just to practice? Of course, yeah, but would it be necessary? Probably not. Okay, so some database products, such as Microsoft Access, automatically creates indexes on the primary key. So that's good to remember that that already is there. So anything we want to put an index on would be something else in there. You can have indexes on combinations of names. So for example, if you're looking for names, you could have a combination. You could have first name, like I want to know how many people are named Audrey. I want to just look for Kinases. I can do a combination of first and last name to see if someone has the exact same name as me. Good luck with that one. But, you know, like my dad had someone in our same town with the exact same first, middle, and last name. It happens, right? So if you wanted to know the exact name, search just for that, you could do something like that. So all that being said, we put indexes on tables, or specifically a field inside of a table, in order to speed up queries. So that is what we do and why. Put indexes on tables to speed up our queries. Right, okay, so we'll do a quick example here because create index is something we can do in Access. So we're going to create an index on our MyStates table. The index has its own name, MyStates index. And for Access, I have the to make and to check, like step by step where to click. So I'm going to switch over our applications. Okay, so now we're back to Access. I have the MyStates table opened up here in our design view, so we can see exactly what's going on. So we have the field names, and you can see here it says, yes, indexed. My name, no, it's not indexed yet. My population, yeah, it doesn't even list it as a possibility right there. Okay, and that one might have only popped up because I'd already messed with this a little bit. Okay, so, oh, the other way to check it would be to go to database, or design rather, and go to the lightning bolt indexes. And we have our list of indexes, which is 1. Great. So you go back to the query. So create design SQL. I already have our code copy pasted in here. I'm going to run it. Oh. Can't edit the table if it's open. All right, let's try that again. I'm going to run it. Did it do anything? It didn't even tell us. How rude. But if we go back to my states and go to my name, we see that now, look, it is indexed. So even though it didn't like tell us those did anything, it's did. And look, it's right there too, or do the indexes. So that easy. That is our easiest little thing of our creates, other than the database itself that you don't need to do. And here, if I said, you know what, I don't want it to be indexed anymore. I've decided that this is not worth it. I can say, nope, no more index. I'm done. And it's fallen off of the index list.